from TM R&D to share his expertise on long-life wired broadband. Please give him your round of applause. Thank you.
Thank you. Thank you so much. Very pleasure. Yeah, please wake up. Okay? I know a lot of people makes people dizzy, right? Just wake up. So I want to talk about long life wired broadband. This title was given to me by you guys. And I am working for Telecom Malaysia, Research and Development. It's here where we live. This is the building. Anybody came in here? None of you visited? Yeah, I feel more comfortable to walk. So anybody visited us inside the jail? None of you? None of you? Yeah, you visit us. Please do, because MMU is our sister. MMU is owned by TM, and we would love students, postgraduate or undergraduate, to come to our labs. You can do some lab attachment. If you are interested, you are more than welcome to come and do your lab attachment with us. Anyway, before 2001 R&D, just I want to give a glance on here, where a division was a division in TM, and 2001 become an R&D company. And it's been recognized by the government that we are on R&D. We are having 24 PhDs, 120 masters, and 135 degrees. So degree mainly in software, and apps, and IoT. So we have 434 guaranteed patents. They are from everywhere: US, Canada, Europe, Japan. And we're having around 1,000 copyrights, industrial designs, layout integrated circuit designs, and trademarks. So mainly R&D, we don't do products, we don't consider products. So it's a solution and business. So okay, what we do R&D? Mainly four things: connectivity, where I come from, this is digital services, productivity tools, and EQ. I'm going to talk a little bit more detail in the next slide on all those four, okay? But we are standing on the shoulder of giants because we do research. You prove anything, then what next? What next? If you can't manufacture, what do you want to do? So lots of vendors, they are for TM, like Huawei, Fiberhome, Alcatel-Lucent, and Juniper, and ICT, and National Institute of Communication in Tokyo, Japan, Foundation in the US, and all those, we work with them hand by hand. And after we finish, we ask them to supply the display for utilizing our technology, and then when they sell this technology either to TM or somewhere else, there is a share for us. And so we are very, very active in standardization. I can say proudly last year, AFSAN, most prestigious standardization body, Full Service Access Network, was held for the first time in Azerbaijan. People came from 82 countries around the world. And they participated in a few papers, and one of them is just going to ITUT. It's for the first time. So we are working very closely with TM. It's in Netherlands for copper technology. We are working with Georgia Tech in RF technology. We are working with the Broadband Forum, and I came in, as you are going to see, TM R&D won last year and last year. The best project in UK last year in Netherlands, best project in broadband, which is again very prestigious. And because of that, the Prime Minister invited us and gave us a much bigger business. And we are working very closely with AMTEC, a few agents, to sell our IPR. So when we file, we are granted the IPR, we sell the IPR to some other company who they can use it, take it, manufacture and sell. There are few models, either they manufacture and sell 50-50 or they buy the IPR and it's all theirs, but they pay big money. So here we are in connectivity. I'm going to talk today about, who asked today about visible light communication? Somebody? Before lunch. Yeah. Here, the visible light communication. We are going to talk about radio over fiber. Normally, if you have an idea of LTE or microwave, in the central station, there is an optical signal that goes in fiber all the way to some station, and in there it's converted to RF or electrical, and then it propagates wireless to customer. But each fiber, you need to generate RF at each remote antenna unit. Generating the RF is the most expensive part of the whole story. So people say, why do we need to do that? We can generate the RF once, modulate it, send it in the fiber to remote antenna units, and from there, the remote antenna unit become very dumb, just an interface between customer and the central station. So it is all centralized. I am going to show you a field trial in Sydney. If you hear of Sydney, some area somewhere close to Cal. FTTH, fiber to the home. Right now, TM is using GPON. Right? GPON is not good. There are lots of conditions for GPON. Now people talk about NG-PON 1, which is XG-PON 1 or XG-PON 2. Then people talk about NG-PON 2, which is TWTM-PON. Then people talk about FlexiPON, which is NG-PON 2 with many wavelengths. Then people talk about NG-PON 3, but we are still in GPON. So we are doing very big research in GPON, which I'm going to share with you because it's a wired broadband. When it's wired broadband, I want to talk about GPON and about copper. That's the wired. LTE and RF is mainly wireless, right? And I line here, okay, let's go to LTE. LTE, we are having a very small physical spectrum, 850 megahertz. That's for FDD. There's FDD, LTE, and TDD, right? Time domain and frequency domain. And TDD is around 2.7 gigahertz, but it's not utilized. It's everybody going FDD. So with 850 megahertz, we managed to get 75 megabit capacity for 3 kilometers radius. So imagine within these 3 kilometers, lots of people in there, so they're going to share. And the closer you are to the station, the bigger bandwidth you get. As long as you move, the bandwidth drops. The most disastrous when you come to the border, you go to another cell because there you are connected to nowhere. That's why if you are using your Viber or Skype, hello, I can hear you. Then you drive a little bit, then okay, you can. Because you're getting closer to the next station, right? So there are a few technologies we are using to make our customer avoid that. One of them is the MIMOs, then relays, the small cells. There are many technologies actually. Then something called time scheduling, where if you are in the middle, instead of being connected to one, you are connected to both of them. So you're having the double of the bandwidth. There are a few technologies we are doing right now, and something called, I don't want to go too deep and detail and to be boring, but something called in-band relays where the frequency from the macro station to the small cell has to be different from the frequency from the small cell to the end customer. Because if it's the same frequency, there's going to be interference, right? So what you need to do, you need to have two frequencies. Means you need to pay more money and need to make the spectrum very congested, right? So right now I have a team of 12 people. And most of them PhDs actually. They are working on a device. We are working very closely with Common Networks in Silicon Valley into designing an in-band, we call it, in-band relay or in-band small cell, where you are using the same frequency for downlink, uplink at the same time. You don't need to wait. So if this we can get is a breakthrough, then for Cooper, you know, and Cooper technology, I don't know if you know, there's ADSL and VDSL, where ADSL is very boring due to the all what you call routing, yeah, and modem, and then VDSL. Now TM is having millions of kilometers of copper around the whole nation. So what to do with it? If you want to vaporize, it's going to be very expensive. So what we're going to do? So there are a few technologies, some called VDSL Victory. We managed to go using the same copper cable up to 98 megabits per second, which is good. If you want to go for higher technology called G.fast, we managed to go up to 1 gig per second. But the distance has to be not more than 250 meters. Meaning, we have to utilize, before applying this technology, we have to utilize something called FTTDP, fiber to the distribution point. And in order to do this, lots of technology is there because you need to find the right place for the FTTDP and how to power it up. Is it reverse powering? Is it forward powering? A list of questions you need to answer. You have to be very smart to do the right solution, because if FTTP very close to the customer becomes more expensive than fiber. If it's far from the customer, you did nothing. There's no solution, right? So all those questions you need to answer. Anyway, SDN and NFV. Anybody here with this technology? None of you? None of you? SDN and NFV is very, very, very important. This is a hot cake right now. It's a software-defined network. Software-defined network where, how to say it, everything is in the cloud. Simplify your network. Meaning, traditionally, we have OLT, ONU, these labs and SANs, right? Routers, switches. Each router costs 30,000 USD. With this technology, you don't need it, because after USD and it, you are virtualizing it. It's not there anymore. Everything is in the cloud. Why do you need this? Network becomes very cheap, very simple, and no fault rate, no customer trouble tickets, no power drops. Moreover, if you want to apply new technology or new service, like apps, very fast. Everything is just in the cloud. And to upgrade, it's just through software. So here, imagine this is around, I'm surprised you didn't hear of it, it's around 25% of TM R&D working on SDN and NFV. It's all simple design network. We want to do, we call it EQ. EQ means effective, elastic, and efficient. Very effective and very elastic and very efficient. So you can modify very fast within a command at the software. Here, smart people. This is city boys who want to on the aircon using smartphone, cook their noodles using the smartphone, make coffee by smartphone. Crazy, lazy, yeah, you're right. Yeah, start their car, everything by a smartphone. If you have a smartphone, you do everything. So they work on digital, smart city, smart parking, as my colleague from Memos was talking today morning. Smart health, you put all those things, and you think your diabetics is good based into this device, but then this device wasn't well connected. Anyway, so here, machine to machine and IoT and smart things are generated just to make money, just to generate money, to make money, be rich. Because sometimes we create technology, we provide it to you, and we make you addicted to it, and then we make you to pay. And life without it was very good. Now, if people divorce because of Facebook, right? And people they ask how people used to live 5 years back without Facebook. As if Facebook is something we cannot live without, right or wrong? So we come out with this technology and we give it to you for free, but in order to use it, you have to be connected and then you have to pay money. So our boss always say, make sure every time our customer touch the phone, pay us money. Do apps, do apps, do apps. Then here, processor tools or productivity tools, these tools and processes are made to help TM serving the customer either new technology, new bandwidth or higher bandwidth or capacity or speed, or generate revenue, make more money. So there are like big data. If you are having around 2 million customers. If you are having a big data, with big data, we know where our customer, which area we can generate more money, which area create more problems, the fault rate is very high, stuff like that. It's all through big data. So you don't need to know this. Here is the business. So you know, TM started in 2008, whatever called HSPT, high-speed broadband, right? And launched officially in 2010. So we have, like Unify, we are having around 1.6 million customers, right? And then we are providing triple play, voice, data, and video and audio, and then right now we are starting this year the HSPT second phase. The first phase for Glen Valley and KL and big cities where there are lots of money. Second phase for maybe smaller towns and kampong and rural areas. So at the very beginning we provide 5, 10, and 20. Right now, this month was launched 50 and 100, and I think 500 very soon, maybe next month. So why we are doing this? You see, in 92, 100 gigabit per day. 100 gigabit per day. Now, 35,000 gigabit per second. You imagine how exponential. This one is in exabyte per month. It used to be 44, 121 exabyte. Exabyte, I don't know, 10 to the power, I think 300 zeros, I don't know how many zeros. Huge, huge. And if you see here, for example, smartphones, 2013 a little bit, now 2017, huge. TV, now 4K. Imagine the 4K 30 megabits per second. 8K is there, around 100 megabits per second. Our neighbor Singapore, they provide 1 gig to the customer. 1 gig, imagine, just 5 years back, if you say, I'm going to give you 1 meg, whoa, this is too much, what am I supposed to do? Now, 1 gig, people want more. Very handy, give me more, give me more. Because lots of demand. So even tablets, just within 2 years back, we are 2016, right? 2 years back, see, 3 times. 4 years back, 3 years back, nothing. So the demand is huge, it's exponential. And that's why broadband is something very, very, very important. For Trico, what we want to do? See, growing number of applications. Every day there's new apps, every day. Every day. Nowadays people people, wherever they go, they use the Waze or Google Map. Wherever they go. Even they go 10 times to the same place, they use the Waze. People tend to be just a machine. They don't think. Even somebody asks, what's your phone number? Oh, sorry, let me check it. You never call myself. So we become more machines, right? More application is there. Number of mobile users, my friend today morning said 50 billion IoTs. 50 billion, man. That's based on Cisco and Ericsson. Other people say 100. The whole globe is 7 billion. Imagine, for each one is connected 13, 14 devices or IoTs. It's crazy. You are a robot walking on the street. Everything is connected. So again, for telecom, this is good news. This is very good news. Because people can live without oxygen, but cannot live without us. Right? So we need to reach the unreached. All those places in highways, in kampong, in village, in wherever. Reach them. Because the more, see, for telecom, you pay only for the infrastructure. But once it's there, you keep milking the cow for coming 10, 15 years. Right? And then for LTE, again, my friends talk about 5G and 4G. You need a broadband. You need a broadband to cover this and to reach everywhere. And then you need a broadband for the LTE. Because the backbone of LTE is fiber. Right? You cannot live without fiber. You cannot. So if you want to give the fiber station LTE, a normal GPON with a backhaul of 2.5 gigabit per second, this is a joke. Definitely, if you want to have a bigger capacity of LTE, when you talk about millimeter wave, you cannot go for GPON. You have to go minimum for a GPON 1, which is 10 gigabit. Then, all those high-rise building and capacity and demand is very high and converge because, listen to me, everybody, please. It's very important topic. Now, you are a customer, and each and every customer wants 3 things. Number 1, want to be mobile, right? Number 2, want to have a higher bandwidth. And number 3, what else you want? Yeah, I don't want to be high ticket. I don't want to be high bill. So I want to be mobile. I want to broadband, but I don't want to pay at the end of the month big bill, right? How can I achieve that? If you want to be mobile, how can I achieve that? What are the technologies that make you as a customer mobile? So far, 2 technologies, right? Wi-Fi and LTE. What else? WiMAX is not there anymore, dying, right? So LTE and Wi-Fi. What is the capacity of Wi-Fi? 56 megabit per second. You go at the coffee shop, use your Wi-Fi, you hardly can open your Facebook, right? Because it's shared. The other one is LTE. The same story. Even with MIMO, we managed to go 150 megabit per second. Yeah, it is not good. So here is the solution, where half of it fiber and last mile is wireless. So you will be converged means seamless integration of 2 or more technologies together work in one system. It's not all wireless. So fiber can go up to 1 terabit per second. Can go 500 gig. Can go to wherever we want. Wireless limitation is the attenuation, is the coverage. If you put them together, you are mobile and you are broadband. And that's what we call converged. So, since the talk is wired, sorry, right now we are having GPON. The distance, even, trust me, I came from the field. Even 20 kilometers cannot be. Maximum 16. From the exchange to the customer. Maximum 16 kilometers. But let's say 20. And the bandwidth for downlink is 2.5 gigabit per second. I am saying in Singapore they give 1 gigabit per second, meaning each core, each fiber, if you want to use GPON, can go to 2 customers. Finish. The capacity finished. So if you are having another 2 customers, another 1 fiber. Another 2 customers, another 1 fiber. If you're having a TAM of 1 million customers, meaning you will be having 500,000 fiber, which is unbelievable. The whole town will be fiber, right or wrong? Cannot be. It's very funny. So NG.1 is either XG.1 or XG.2. XG.1, 10 gigabit per second downlink, 2.5 gigabit per second for uplink. It's good. But in 2016, for the first time, the uplink exceeds the downlink, because normally people say the downlink is much bigger than uplink. But this year, also people upload YouTube, upload photos. Every time you go to a restaurant, you take few photos and put in the Facebook. Every time you go on holiday, you take lots of videos, you put in whatever, Twitter or whatever, right? So upload has become, lots of demand. That's why we go to XG.2. XG.2 is 10 gigabit for downlink and 10 gigabit for uplink. Then TWT and bond, where we are, here we are. TM R&D, we are here. TWT and bond is not time division only. T is not time division, it's not wave division, it's both of them. Time and wave division. So we managed to go 40 gigabit per second for downlink and 10 gigabit per second for uplink, which is very good, absolutely good. And this technology is very beautiful. I'm going to talk about it today. Okay? Imagine the distance of this technology can go up to 40 kilometers, and the number of customers can go up to 512. Now, to share with you, for GPON, can go up to 64 based on the standards, but we don't know that yet. Because 2.5 gigabit per second is very small, very little. So, if you are asking by law, by Malaysian law and regulation, minimum to your doorstep must be 80 megabits per second. When you subscribe to 20 megabits per second, we give you 80, but you pay for 20. When you subscribe to 5, we give you 80, but you pay for 5. Because 11 or 12, I think, megabits per second goes for your hit. And the rest for data. So, for GPON, distance is a problem. It's only 20 kilometers. And demand is very high, and GPON cannot give. And the bandwidth, if 64, the maximum you can provide to each customer is 39. Assuming no loss in the way, which is also useful, right? So, see the distance. This is our exchange. This within 20 kilometers. You just think of it. Just think of it. And there is customers 22 kilometers from the exchange. What they're going to do? You get my point? You get my point? So the next one is 20 kilometers, and there is here a customer. Sorry. These customers 22 kilometers. What they're going to do? Problem. They put something called remote OLT in here. And then again, so it's very, very costly. So with TWT and bond, we can go to all of them because the distance is 40. Right? This is number one. So. Number two, density. Because in GPON, maximum you can get, now in TM topology, they use 4/8. Means one fiber split to 4, and each one split to 8. So 8 multiplied by 4, 32 customers. Maximum. The one core. One fiber core. So if you are having 33 customers, number 33 will be having one core all alone. And this guy keeps paying us for the rest of his life. He will not cover the expenses to his house. Right or wrong? It happened, I'm telling you the truth. I have seen it. Some customers, they live in luxury condominium and they call, we want fiber to the home, we want 25. Okay, fine. When we go there to lay down the fiber, you need to, like Shahala, overhead fiber is not allowed. You have to dig and put the fiber in the ground. Then you have to take all the tile. And then you have to put the fiber. And then you have to pay to return it as it was. Right? And it's very expensive. So some customers, we say, sorry, we cannot. Because you cost me 60,000. And if you want to pay me 150 ringgit a month, you will die, and your children will die, and maybe their children, and I will never get my 60,000. Imagine. But in some school or hospital or something, that is a different story. Even we don't make money, we do it. Because that is social, not customer, you see? So I came in here. So the density is limited, so every 32 you have one core. Every 32 you have one core. But with TWD and PON, you can go up to 512 using one core. So the capex, if you know what I say, capex, capital whatsoever, is minimum, and opex, and operation. Right? Capex and opex are very minimum. So the bandwidth should see in GPON 2.5 gigabit downlink, 1.25 for uplink, which is very little. For here, 40 gigabit downlink and 10 gigabit for uplink. This project won last year the broadband info vision in UK. TM R&D got the best project. So this is the TWD and PON. Maybe so the benefits and impacts. So really for ultra broadband can go up to 40 gig. Life made easier. Everybody can enjoy 100 or 200 megabit per second, and reduce OPEX and CAPEX because one core, easy to maintain, not hundreds of cores. And provide better services and bandwidth, definitely reach more customers, sure, from 32 to 500 plus. Smart home, city, learning, video conferencing, we can provide because big bandwidth. And energy saving, this is, if I want to explain it, is very difficult because there are many ONUs that IONU that doesn't work. There is automatic switch over within here. So it goes to another wavelength, so I don't want to confuse you anymore. And also we contribute in AppSun, we contribute 2 or 3 of you papers into AppSun, which is an international standard body. See, all those support more than 150 megabit per user and support longer range, up to 60 kilometer, support scalability and green and coexist. Oh yeah, and this technology can coexist with the current technologies, so you don't need to change that paper or change your network. So very high bandwidth, maintain, okay, so everything in TWD and click. So compared to the other technologies is very good. And here is the looks boring, this one. So if it looks boring, forget about it. This is more boring. This is strong, which is some, okay. Before I go to here, I want to share with you video. You want to see video? You want to see video? Yes. Sure? This is the team who made this system. This is our lab in TM R&D. This is the OLT, which is supposed to be the exchange. This is the NG pawn, next generation pawn, car, the OLT. If you can organize a visit to us, I can show you the system in real. This is the extender that make it go up to 60 kilometers from 16 or 20. This is all designed by us and all fabricated by us. This is the fibers, 20 kilometers. This is the first stage. And there is down another 20 kilometers. Here. Here. See? 20, 20. So around 60 kilometers. This is the second stage. Fiber. This is the first optical splitter, 1 to 4. And the other one, each one is to 32. This is the all-new, which is supposed to be at a customer house. We have designed this and fabricated in China. This can exist with current chip pump. This is the whole team. So maybe talking a little bit about Kuba network, because Kuba is also wired, right? It's not only PON. So, you know, now HSPP second phase. HSPP second phase means urban areas, outside those dense areas. So the target is around 59K home pass, 1,000 in 3 years. They are providing Unify, and again this HSPP one, which is closed. We are using VDSL2 Victory and FTTH for high-speed broadband, and also for suburban broadband. So again, providing VDSL2 and FTTH. And this is very important for any telecom engineering. You must understand this job actually. From ADSL, they call it XDSL anyway. From ADSL to VDSL to VDSL2 to VDSL2 plus to VDSL3 to VDSL picturing to Gigabit fast. So this is very important technology for networking. If you are a networking engineer in here, it's not only PON, also XDSL is very important. So we spend here lots of money, and we spend here lots of manpower. The team for Gigabit fast around 32 people. They are working for the last 2 years, and they managed to go up to 900 to 1 gigabit per second using copper. So now you don't need to fiberize. And here, victory is very important. We managed to go 100 megabits per second. But here is time domain, here is a frequency domain. So there's a new technology, people talk about it, VDSL3, which can go up to 600 meters and 400 to 500 megabits per second without changing the infrastructure. So it's going to be, again, hot cake. This is the scenario of TM, either ADSL or copper, more than 5 kilometers, or fiber to some cabinet. We call it SAM. And then less than 3 km, this is VDSL2. Or fiber to VDSL2 plus services cover less than 1 kilometer. This is the current scenario. Then they use FTTP, okay, maybe next slide here. They use FTTP, so fiber all the way, and here, less than 500, not 250. Only gigabit fast 250, but for vectoring or VDSL, you can go up to 600 or 700 meters. Okay, so you can get here at the customer, you can get between 100 meg to 1 gig, depending on the technology. But this FTTP is an active device, so how to power it up? That's the question. So the team in TM R&D, they use remote powering. Remote powering, this copper, when they replace it by fiber, they leave it here, they leave it there, and this copper used to power this DP, this one, from this Samsung. Because we can power it up from customer by reverse powering, but in Malaysia is not allowed. From the place where I come from, is allowed. But here by law, we have to follow, it's not allowed. So meaning all these technologies are there, vectoring right now with trial and TM right now. Gigabit fast is in the future. Gigabit fast implemented only in Swiss Telecom because this is Switzerland, small country, and so there is no long distance for copper. Easy to apply, easy to utilize the gigabit fast technology. What I want to say. Just this sentence, what I want to say for vectoring, for gigabit fast, what we do, we simulate the noise, the crosstalk, we inject the same thing, but at the reverse, so both they cancel each other, and you have to just understand that, you know. Both they cancel each other, and you'll be getting a clear line, and you can get a bandwidth, high bandwidth. So here the team, they work for half an hour, stay in the Starbucks for 3 hours, and they take some photo and they come and say, okay, we did our work. This is all the, yeah, I follow them actually. Where were you? Oh, say, we're working Starbucks. So here the copper cables problems. Sometimes the splicing, sometimes cutting or cross-talking, sometimes in Malaysia is humid and hot. So that makes it dioxide. This thing, what we call dangling bomb, something dangling, or they call it a bridge tab, if not connected, can create lots of problems. Okay, for you engineers in the future, create lots of problems because that reflects and cause noise. So you see, for gigabit fast is roughly 900 plus megabits per second. We can control the bandwidth for downlink and uplink. So around 750 downlink, 200 little bit extra for uplink. For 50 meters, 100 meters, 250 meters, you can go up to 600 meters per second. Using the same copper cable, which now you cannot get 1 megabit. This is my favorite project. We call it GCOM, not this COM. COM means collaboration on optical radio network. We went to China. We worked with Fiber Home. Fiber Home is a Chinese company. We went to China, and where the name comes from, and it's for the first time we see corn, black corn. Black. Have you ever seen black corn? It's black corn. So that's wow. Then we decided to name the project corn. Yeah. It's true. It's true. It's true. But our CEO, his name is Gubi Koro. So he asked me, what's G? I say, sir, it's Gubi. Nothing good. So this is a very extremely beautiful technology if you can appreciate it. This is a complimentary for FTTH. And okay, I know you don't want to read all this. Let's see. Okay? So you see how beautiful this technology. We are putting fiber in here and up to here, and then there is a river, there is a lake, there is geographical or human-made obstacles that fiber cannot go all the way. Then all the RF signal is generated here, modulated, sent in the fiber all the way to remote antenna units, and then go wireless. And we managed to get, wireless I'm saying, we managed to get 1.8 gigabit per second. And yeah, I will show you, this is the lab, okay? And inside the house, I will show you now. You don't need to know this. This is here, what I need to say, the RF is all engineered with the ORT and sent to the remote antenna unit and then wireless to the house. The beauty of this technology, you can go millimeter wave, low frequency, high frequency, whatsoever it is. So my colleagues who talked before me about millimeter wave, just tune it. Your millimeter wave means 5G. You see, this is our network. Any network engineering here? You guys engineers or what? Are they? Yeah, I know. They are doing engineering, right? Anyone of you doing network engineering? None? Okay, means you are going to appreciate this. Okay, for general knowledge. We are having a signal station here. We call it what? This thing is connected to metro E. Fine, somewhere in the sky. And we are having a fiber. And all the way coming to the home. This is what we call optical network. Our optical network, right? And here we cannot go. So we use this technology as a complementary to this. And it's wireless, so each one of those can go up to actually point to multi-point. Each house can get 100 megabit wireless. 1 to 20. Fine? So this is the scenario, but not network, but this is what we call drop fiber. So now we don't have drop fiber. This is the source of every problem in telecom. Drop fiber. You ask any telecom. 84 customer trouble tickets come from here to here. And from here to here. This is also drop fiber. Either underground or by 84% of the problems. Because passive component is the one that causes the problems, not active. Fine? So by making this thing last mile wireless, meaning you are reducing, if not eliminating, all the customer trouble tickets. Okay. So right now, we don't have all that, these drop fibers. We are having only a remote antenna unit in here. And there is no RF signal in here. Everything is generated in here and sent. So you can have 1, 2, 3, 4, 5, 6, up to 20. One remote antenna unit, and this remote antenna unit is very small. You're going to see it in reality. I'm going to show you. I'm going to show you. This is the one. Where is it? This is the one. This is in Simini, okay? This is what we done in Simini, using this technology. Say this is our ORT, fiberized to FTC, fiber distributed cabinet to remote antenna unit, and then this is wireless to those houses, and they can see HD TV at home, even they can see 4K TV at home, because they can get 40, sorry, can get 100 megabits per second. Wireless. Imagine, just touch your smartphone. You can see the YouTube all. So, successful deployment of radio fiber technology in here. And really we are so proud. I am so proud we have done this technology. This technology is very complicated. Very, very complicated. But anyway. VLC. This is the VLC, okay? So, visible light communication. See here? Just shine the light on here. And using the light as a medium, we can transmit data. So we can go light illumination and wireless communication or plug and play and whatsoever. What I want to say in here, just to cut it short. If you put a LED, you can buy one ringgit from wherever, 7-Eleven, and you put at your home. The light we can use as a medium to transmit internet. Till now, we managed to go 20 megabits per second, a distance of 3 meters is not good. Because we are using OOK modulation technique. Now, the phase 2, we are using OFDM. If you guys write, please write those things. Maybe you can check the Google if you are interested to know more. OFDM modulation technique, where we can go up to 10 meters and around 400 megabits per second. So we have done exhibition last 2 weeks in Cochin, and the Prime Minister came and we explained to the Prime Minister and they are thinking to put in the highway between Cochin to what was the name of Kinabalu or something? Yeah? So all to have a broadband in that area. Even from KL to Johor to Penang, the lights are there. Just use them and transmit data. So you don't need Wi-Fi, you don't need LTE, you don't need 5G, you don't need this antenna, you don't need power antenna, high antenna, nothing. You have light, you can use it. So here is the prototype. Again, this is in my lab. Please, if you come to Cyberjaya, I can show you this. So it's point to multi-point. You can media player, notebook, smartphone, whatsoever it is. And the higher you go with the light, the coverage is going to be bigger, right? So it's point to multi-point. So here we are seeing a 4K TV. Here is the server, and we are seeing it on the TV using the light. Communication. Here is we have something called TMCC. TMCC. I don't know what CC. TM, I know telecommunication. CC is city center whatsoever. This is there. If you go there, you can see. So this is in public area, commercial, underwater. You can do it. You can get internet. Because it's not an RF, it's light. Light can go underwater. Whatsoever, many things, applications. Yeah. We were talking about NCMC and we pay money for the NCMC to fit the spectrum. It's a spectrum, right? Here you don't need to pay anything. That part the Prime Minister did that. Because we don't pay anything. We can get internet and don't pay anything. So this is free light, LED, and you can use it for bandwidth. So no license required for this. And today we will talk about Wi-Fi. And trust me, tomorrow we will talk about Wi-Fi. Light. One thing very important about Wi-Fi, one thing important, security. Because when you are a subscriber to Unify, you have Unify at your house. Once you go inside your house and open your laptop or gadget whatsoever, you can sense all your neighbors, right? I mean, if you stay in condominium, very close, maybe if you stay in bungalows, far distance, different story. I stay in condo. Once I go, I can see all my neighbors, right? So if I can hack them, I can go into. I don't do that. But why? Because Wi-Fi is at 2.4 gigahertz, right? It can penetrate the wall. But light cannot. Meaning, if you are having an internet here, due to this light, and there's a wall, light cannot penetrate, right? Means your neighbor or whoever it is cannot hack. Sorry? Anybody? Ask anything? Yeah, cannot. Because light cannot penetrate, right? So this technology could be used even for high security whatsoever. So, what's this? Yeah. This is we are working with many partners somewhere around the globe. Here is what I say. Broadband Information 2014, another one, 2015. This is we won these 2 awards. This is the Prime Minister Award. for DLC. And we got, this is the oyster drop, this is from Mexico. Whatsoever. And thank you, bye.